For Chapter 11, Building Geodatabase, we are going to work on Exercise 2. And we're going to start ArcMap. And then we're going to open the Arc Catalog window, expand the Getting to Know ArcGIS folder, double-click Chapter 11, and then double-click Exercise B Data. And we're going to right-click City Data Geodatabase. And once you double-click the geodatabase, and then we can right-click on it, and we can do copy, and click paste to my data. So we're going to right-click city file. Now my data, this is the newly copied one. And we're going to right-click on it. And then go to the option, New, and New Class, New Feature Class. So for the new feature class, we're going to type Playgrounds. So by default, the type property is set to polygon features. So now you don't need to make a change. And we will go click Next. If you completed the previous one, you can just see the correct coordinate system under Favorites. We need to specify a name already exists, and we need to name a different one. Playgrounds _ new. Next. And now for the favorites, we can see our NAD 1983 State Plane, New York, Long Island, FIPS 3104 feet. And we're going to click Next. And we are going to do is double click Next and Next. So for the X and Y tolerance back here, X and Y tolerant, we're going to explain it a little bit. We're going to, the X tolerance defines the minimum distance between two coordinates before they are considered equal. So we're going to accept the default value. A database storage configuration allows you to fine-tune how data is stored in a fine geodatabase. You will accept the default as well. Click Next. So the fifth panel of the wizard displays the field names, data type, and field properties that belong to the new feature class. Object ID and shape are required fields for geodatabase feature classes and are automatically added by the software. The Object ID field stores a unique ID number for each feature in the class. The Shape field stores each feature's shape and location. Depending on the type of feature class created, ArcGIS also creates and maintains measurement fields. A shape underscore length field is created for line feature classes. Shape length and shape area fields are created for polygon feature classes. The shape underscore length attributes for polygons stores parameter length. These measurement fields appear only after the feature class has been created. So in the field's name column, click Shape. And then file property for the shape fields are displayed. So now we can see field property. We can see here. And then we're going to, in the field name column, that we're going to notice that the geometry type is polygon, right here, polygon. And in the field name column, type inspect date in the first empty row. Field name cannot contain spaces or special characters such as hyphens, brackets, parentheses, or symbols such as money symbol, pounds, percent, or and. So in the data type column, we're going to click empty cell next to the inspect data and click date. Tip: for more information about field data types, we're going to consult ArcGIS Desktop Help. On the Contents tab, navigate to Geodata, Geodatabases, define the properties of data in Geodatabase, Geodatabase table properties, ArcGIS field data types. You can read more later. Another way to categorize Geodatabase features is to use subfields. Subtypes. With subtypes, you can group features into separate classes without having to create distinct feature classes. For example, you may want to classify a road's feature class with the subtypes main, highway, and utility. To create subtypes, you must have a short integer or long integer field in the feature class. The integer is a code that is associated with a description on the Subtypes tab on the Feature Class Property dialog box. Attribute domains may be established for each subtypes. For example, you may want to establish a domain range for the speed limit attribute, which will vary by road type. In the field name column, in the next empty row, type name for data type. And choose tags. In the next empty row, we're going to type borough. And for the tags, we're going to data type also tags. Now we're going to click Finish. In the catalog tree, we notice that a new feature class, Playgrounds, new, is added to our city geodatabase, making a total of 7 features. 1, 2, 3, 4, 5, 6, 7. Because this one already added for us. Now that you have added 2 attribute fields, you will next create a domain and apply it to the borough field. You create domains in the Geodatabase properties. In the catalog window, right-click City Geodatabase and click Properties to open the Database Property dialog window, and then click Domain tab. So, Properties and Domain tab. In the domain name column, in the first cell, type New York NYC Borough. And it's already typed for us. And we're going to the first cell that in the description column and type NYC Borough. It's already typed for us, and I think this thing already being created, so we just go through it real quick. In the domain property list, the default field type value is long integer and the domain type value is range. So the field type must match the data type of the feature class it is being applied to. Because you made borough a text field in here, and you must do the same here, change the field type to text. And now the second part, under the domain properties, click long integer and change into text. The domain type is changed automatically from range to coded values. Okay, now we can see here coded values, field type is text, coded values, default value, and value. A coded value domain is used when the attribute value you want to enforce are best defined in a list. The value may still be numeric because numbers are commonly used as codes for descriptions. A range domain is used when the values you want to enforce are quantities with upper and lower limits. In the coded value list, in the lower portion, coded value is right here, coded value, and click the first empty cell column, type M. So it already did, plus, and then we put Manhattan, and in the next rows, we're going to following the codes and the description. B is for Brooklyn, and X is for Bronx, Q is for Queens, and S is for Staten Island. After a coded value domain has been applied to a feature class, you will be picking from a list from these descriptions when you entered attribute values. The coded values are stored in the geodatabase, but you will see the description in the attribute table only. Then we're going to hit OK to apply the domain to the playground's feature class. Now that you have created the attribute domain, you will next apply to the borough field of the playground feature class. And what we will do in the Arc Catalog window, we're going to right-click the playground feature in class in here, and we're going to click Properties. And only one feature class property dialog window, and then we're going to click Fields tab. Let's re-click again. General fields. Okay, now we have the Fields tab selected, and we're going to click Borough, and click Borough in the field property frame. Click the empty cell to domain and click NYC Borough. Domain NYC Borough. And you have now created an attribute domain and applied it to the borough field. Finally, you will assign the field as a default value. You are focusing on Manhattan as your city area, and you will set Manhattan as default. Whenever a playground is added to the feature class, it will automatically get this value in borough field, but you can easily change the value as needed. So now in the field property frame, click the empty cell next to default. And type M. Then the code for Manhattan. So M is the code for Manhattan, and we click apply, hit OK. And now you can set a default value for a value without creating a domain. If a domain is applied, however, the default value must be valid domain value. Restore the Arc Catalog window to the position you prefer and exit the application. Click No if prompted saved for the changes. So now we're going to click everything here. No, and we are done. Thank you. And then we're going to move to Chapter 12, Creating Features. So here we're going to learn about digitizing data, and which is often involved placing a map or a photograph on a digitizing table, a drawing table connected to a computer, and tracing features with a puck, which is a device similar to a mouth. But now in a variation we call heads-up digitizing. More common today, features are drawn directly on the computer screen with a mouth by tracing an aerial photograph, a scan map, or other spatial data. Spatial data points can be also collected from GPS-enabled devices, which can then be uploaded to